Good morning. This is Tim Stewart. I'm president at Visual Decisions, and we're here today to talk about all the different things that you can do with Kepware. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory and the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes have to be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and to help establish a true data-driven manufacturing culture. So when we look at Industry 4.0 and look at the fundamental steps within there, connectivity is one of the very first things you have to establish in order to get to that Industry 4.0 end game. And that's the primary thing that we're going to be talking about today, is utilizing Kepware to establish connectivity on the manufacturing shop floor. So traditional connectivity doesn't scale. Back in the dark days before Kepware existed, everything was a point-to-point connection, and you had to write your own drivers. You had to establish, connections from one device to the other device and so forth. And whether that was done just through a standard protocol or a software development kit or a hardware gateway, it made things very difficult. And when you don't have that, good data access and so forth, all of the things that you're looking to enable in terms of, SCADAs or historians, quality management, Internet of Things systems, et cetera, just don't work as well as you would like them to. If you can standardize that connectivity, it makes it much, much easier to implement those additional value-add systems and to start driving improvements based upon having those different systems in place. So what is Kepware? Kepware provides the kind of middleware connectivity software that bridges between hardware devices and software applications. And so if you look at the little representation here, we have the different devices down in the bottom. It could be PLCs or OPC servers, or flow computers, or sensors or actuators or CNC machines, et cetera. And what we're doing is we're utilizing Kepware's device driver library of over 150 drivers, and I'll show those in a second, to connect to these different devices on the shop floor. And then we have the ability to say how we want that information to flow to the higher level applications up above. And then we have a lot of different capabilities within Kepware itself that I'll be talking about throughout the course of the presentation today. So when I talk about the breadth of connectivity for Kepware, it really provides the standard in the industry to show all of the different things that you can connect to. There's very little on your shop floor that won't have a standard connectivity already existing between Kepware and that device. But there are ways to get connected to just about anything that you have out there. Very briefly as well, Kepware can be installed at the edge. And if you have more questions about that type of use case, let me know, and we can go into that in a separate conversation. So when we look at the manufacturing shop floor today, and with the rise of Industry 4.0 and I-IoT systems and everything else, there is vastly more complexity than there used to be in terms of connecting to the shop floor, gathering information from the different devices, and then utilizing that information to drive improvements. And so really, Kepware is an essential part of that shop floor architecture in order to be able to gather that data and utilize it effectively. So it helps you to connect to the different devices that are out there, manage those, monitor them, and then provide control. So when we think about ISA 95 and level 0, 1, 2, 3, 4, in terms of the actual assets themselves, all the way up through the different business systems, the way that this has traditionally been done is that you have point-to-point integrations at every single level of that hierarchy. And as you want to change out, one business system for another, or one operations management system to another, or you want to add another one, what ends up happening is then you have to redo all of those different points of connection. If you have Kepware and Kepserver implemented, then you can use that to abstract the different machines and different controllers from the shop floor, and connect those directly, connect Kepware directly to those higher level systems to provide that information to those on a much, much easier to manage basis. So essentially what we're trying to do is to simplify that implementation, to accelerate the adoption and time to value, and then to enable scalability and future innovation as well. And we do that by providing standardized data access, scalable architecture, and also security best practices. So some of the challenges that we're trying to overcome from a communications point of view, connectivity, and we're providing that connectivity to a huge list of devices and applications. The data quantity, quality, and reliability, and Kepware provides industry standard ability to scale the amount of information that you're taking from each device, and how quickly you're taking that information from the device, and security, usability, and having that interface that is extremely easy to use, as well as external programmability for that. And then, continuously changing technology and being able to utilize Kepware to kind of abstract the complexity of the shop floor, so that as you're changing your technology within your environment, you have the ability to rapidly do so. I'll take a pause at this point and note that we do have a question and answer for this session today. So if you have questions, please feel free to enter them into the Q&A. So I've kind of gone through the basics really fast, and what I'm going to get into now are the 6 critical features within Kepware itself, and then also some additional capabilities that exist as plugins. So from that 6 critical feature point of view, you have connectivity is essentially the single base feature within Kepware. And what we're doing is this is the layer that has those 150 plus different device drivers that allow you to establish that connectivity to pretty much anything on your shop floor, and even beyond the shop floor to HVAC systems and a lot of other devices as well. Aggregation. So you can support connections to thousands of different data sources and provide information to hundreds of applications through a single architecture. And this simplifies the configuration of those connected applications by providing that single point of entry to all information. It eliminates the need to purchase, operate, troubleshoot, and maintain disparate solutions for discrete connectivity, and features a unified configuration for managing connectivity to any data source. From an optimization point of view, it can optimize communications and reduce network and device load through data conditioning and reduction, which minimizes bandwidth and resource utilization by providing only the most critical updates. It offers flexible control for customized load balancing and data collection and information flow. Provides options for protocol-specific communication optimization, and also features machine-to-machine linking so that communications occur as close to the device as possible, and redundancy for critical applications where highly reliable systems are required for maximum uptime. From an accessibility point of view, if you're connecting to the PTC ThingWorx system, it supports that always on protocol. But it also supports the OPC Unified Architecture, Opc Ua specification, and many of the classic OPC specifications as well, including DA, OPC alarms and events, OPC AE, and also the OPC historical data access. It supports proprietary protocols from leading automation software and IoT solution providers. So not just ThingWorx, but additional solutions as well. It supports several IT protocols for integration with on-premise applications and cloud services. And it also supports the export of historical EFM or electronic flow measurement data or historical trend data to files and or databases to industry formats and customizable formats. From a security perspective, it includes a variety of different tools that expand administrators' abilities to control user access and regulate read-write access for secure data communications. It supports a number of secured client standards, SNMP, OPC, HTTPS, to further restrict access to the server. And it supports a number of secure device protocols to meet the requirements of DNP3, SNMP, and OPC Ua data sources. From a diagnostics point of view, it provides robust communications diagnostics to easily isolate and troubleshoot device and application communications. OPC diagnostics provide a real-time and historical view of OPC events between any OPC client and the server. And communications diagnostics capture the protocol frames transferred between the server and any device in real time. Provides diagnostic information through system-defined tags and is accessible to the same clients connecting to the data sources. And event information is accessible within the configuration tool, the ThingWorx platform, or to any application that supports the OPC alarms and events specification. With that, I'll get into some of the advanced plugins that are available. And this is, for me, kind of where the fun really starts. With the advanced plugins, you have the capability to extend the server functionality. For example, if you need to get PLC data into SQL tables for analysis, you can use the data logger. If you need to perform calculation, you can use advanced tags. If you want HDA support, you can use the local historian. We even support OPC alarms and events with the alarms and events advanced plugin. So each advanced plugin is licensed individually, so you can combine and or choose which advanced plugin best solves your data challenges. The advanced tags is very interesting capability. It enables machine-to-machine tag linking, logic, and math functions for operational communications and analysis. It enables users to link two tags, set a trigger based on logical states, and even calculate new values from raw measures. So for instance, if I have two PLCs out there, and one is taking a measurement in kilograms and one is taking a measurement in pounds, I have the ability to not only link those, but do the math to translate those to see how those blend together. So I can execute that math or logic or analysis at the connectivity platform level to bring the data closer to the source. And the advanced tags support 6 predefined tags: link tag, derived tag, average, complex, or maximum and minimum. Alarms and events provides a complete framework for defining alarms. So you can enable users to select which tags to monitor, define the conditions and the trigger thresholds. When a condition's trigger is met, an alarm is sent to the corresponding alarms and events client application, providing the input, output, and acknowledgement messages. It enables users to monitor areas of a process that require attention when thresholds are met to collect and record information for audits, and it supports 9 separate OPC AE standard conditions. So where this can be very helpful is, as you're collecting information, close to the device itself, if you see the need to alarm based on this, even if you're not running an IoT system in the back end and so forth, you have the capability with this extension to send out alarms right away. And those alarms can be handled and translated into text messages or emails, etc., and get sent out to anybody that needs to pay attention to that particular alarm. So by putting this right next to the device itself, as you're collecting that data into Kepware, you have the ability to have those alarms happen very quickly and to take action based upon that. The data logger does pretty much exactly what it sounds like. It logs data from the Kep server to any ODBC compliant database, such as SQL Server, Oracle, MySQL, Postgres, or pretty much any ODBC compliant database that's out there. It provides substantial benefits such as simple installation, high efficiency performance, easy tag browsing, advanced triggering, and store and forward capabilities. This is one where if you don't have an IoT system already in place, where you can handle these things in the background, or if you have an extremely high volume environment and you want to push information directly from the from Kepware to the database first and then read it in from the database into a separate system, the data logger gives you the capability of doing that directly. And so I have a customer that wasn't ready for a complete IoT system, but they wanted to get information from their devices, from their machines, and persist that to a database today. And so as they were beginning this process, with a pretty small investment into Kepware and the data logger plugin, they were able to start persisting that data right away, as they were doing a further investigation into IoT and so forth. But then once they got to the point where they had decided on an IoT system and predictive capabilities and everything else, they already had the database of data in place that they could utilize to train that predictive system. And so by making this decision early, what they were able to do is to shorten the process of having sufficient data to train that predictive system later on. Industrial data forwarder for Splunk. And again, this is something where this can stream real-time device and sensor data into Splunk software and cloud services. It enables organizations to search, monitor, analyze, and visualize machine-generated big data coming from anything really, but websites, applications, servers, networks, sensors, mobile devices, etc. You can collect data from thousands of different industrial sensors and machines, including PLCs, controllers, etc. And then you can add custom metadata to the driver tags in kind of a free-form field for advanced search queries within Splunk. 1 second, let me take a drink. Somebody asked a question whether the recording will be available. Yes, I record all of my different webinar sessions, and they're all available on my website at visualdecisions.com. It usually takes me a day or two to get them posted up. Some of the other additional functionalities that are available are the IoT gateway. This provides the ability to stream industrial control data into IT or IoT applications. And you can do that through MQTT, REST applications, the ThingWorx Always On, and so forth. Opc Ua Tunneling is available so that you can go through, kind of a demilitarized zone and separate your shop floor network from the higher level domain and or the internet. Configuration API. This allows you to programmatically configure Kepware to define what you want from the tags and everything else, and how you want to do communication, and control all of that through an API. So you can, as this shows, use something like Excel to have all of that definition there. You can program things through Python or pretty much any other language to talk to that configuration API, and then drive that down into Kepware. Security capabilities. So not only can you deploy the product using security best practices, you can also utilize the product to enhance your security within your network. Without going into too much detail, this is an area of obviously emerging concern for manufacturers. Number of attacks on industrial control systems has skyrocketed in the past few years, and when combined with the traditionally kind of weak cybersecurity in these networks, this can provide significant risk to the enterprise. And this can be part of a robust defense in depth strategy that reduces that overall risk. And just a little bit more about security, but you can essentially enable different roles and have different permissions, so authorizations and authentications. Local historian. The local historian moves data collection, storage, and access closer to the data source to prevent data loss and improve efficiency with open access and single product solution. So the plugin architecture simplifies communication, provides flexibility, and makes information accessible across OPC HDA. The scheduler enables users to move the scheduling of data requests from the client to the server to optimize device communications across the network if you have limited bandwidth. And you can define the polling schedules for specific tags from multiple devices by time of day or frequency. You can optimize available bandwidth by scheduling when those data communications occur across a network from one centralized source. And you can provide visibility of network utilization to local and remote applications like HMIs or historians via system tags. The SNMP agent provides an easy to use platform for IT professionals to access automation systems and devices. It enables most network management systems to communicate with automation devices and automation systems. And it allows IT professionals to monitor attached devices for conditions, avert and remedy failed internal processes, and fix unexpected external events. So I kind of blew through a whole bunch of functionality there, but what I want to do now is to go through some examples. And the first example I'm going to go through was at a bakery customer that we have. And in this particular example, we utilize Kepware to connect to a variety of devices within the bakery, and took that information, saved it in the database. We did not have any IoT system in this particular case. So what we did was we took that information from the database and we actually pulled it into a business intelligence tool. In this case, it was Qlik, and then used Qlik to display that information to the users and allow them to drill down into that information to identify what was happening on the shop floor and to take actions to make things better. So in addition to the raw data, we also created a little web UI that allowed people to add context to the things that were happening with that data. So when we saw failure events or downtime events or quality events happening, we would pop up on that web UI client a request for more information about that failure, in addition to what we were automatically able to capture from the PLCs themselves. So based on this, what we were able to do is for every failure, we're going to look at downtimes here. We were able to capture, what type of failure was it? Was it an equipment loss, a production loss, quality loss, et cetera? And then within equipment loss, we could look at what category it was. Was it, with the oven? Was it the cooler, et cetera? And then what was the actual cause of that downtime? And for that, we could either look at the tag information coming from the PLCs, or we could prompt the users to enter a reason. And then we also prompted the users to enter comments when that occurred. And so within Qlik, what we're able to do then is to very easily drill down through here just by clicking on the equipment loss bar. It would show us the information for what categories within that bar and so forth. So clicking on the biggest bar of equipment loss, and then clicking on the next biggest bar in the category for oven, we saw that the biggest cause was other, and we got more information from the shop floor then. But if you look at the pattern of failure at that point, you can see that most days had very, very little time lost due to the oven. And then we had these big spikes that would periodically occur. And as we gathered more information, what we found was that the oven shelves were flipping due to a broken pin. The pins on the conveyor as they would go through the oven were fatiguing. And we needed to set up a preventive maintenance interval to switch out those pins on a regular basis. And just by doing that and identifying that that was happening, we were able to eliminate the single biggest loss of downtime for that facility. And we were able to do that primarily because we were getting the information from Kepware that we needed to be able to identify and do the root cause analysis for that problem. Some of the additional use cases from PTC around this: implementing smart maintenance solutions at Skoda. They were able to achieve faster production and better product quality, raising their productivity from 94 to 97%. And then if we look at Lufthansa, with 35 subsidiaries and affiliates, they're one of the leading providers of technical aircraft services in the world. They had a challenge in providing MRO services with kind of a maximum of quality, efficiency, and stability. And what they wanted to do was to be able to create that connected shop floor for real-time asset health monitoring, and then really optimize maintenance around how do you minimize your mean time to respond, how can you maximize the mean time between failures, and then finally, how do you also maximize that first time fix rate, so that when the maintenance team actually goes out to the machine, they have all of the information they need to be able to bring the right parts and tools and so forth with them to fix it that first time. Improving OEE and labor productivity, being able to get the information from the systems for Fresenius that enabled them to do the same types of things that we did at the bakery, where they were monitoring those production lines and they gathered that information to reduce the downtime, improve the quality, and increase the visibility across the enterprise. Faurecia, again, being able to connect to those machines and get the information that was required, And in this particular case, they used the IoT gateway for Kepware and push that information to the cloud and so forth. And by implementing that gateway as the communications medium between PLCs on the shop floor, Faurecia is able to provide customers with product traceability that they require. If you've worked in automotive or if you've talked to automotive people before, being able to provide OEMs with a good picture of what happened on your shop floor can reduce your exposure to warranty claims by quite a bit. And so with that, they're able to also satisfy regulatory requirements and improve the overall product quality for customers. At Brembo, again, being able to leverage Capware to integrate many disparate sources of data, including plant equipment, lathes, mills and robots, PLCs, quality systems, ERP and maintenance systems, and providing all of this provided deeper insight into Brembo's production. And within 10 weeks, they were able to leverage the connectivity of Kepware and also ThingWorx to collect and display this information on various mashups and provide different user groups with real-time actionable data. And another one down east, cider vendor. They were able to monitor their fermenter tanks in real time to get the data from there and be able to optimize their brewing process. And then Evonik, being able to utilize the information to connect to their systems. They were able to do a POC in a small scale first, MTP integration into an IoT platform, and they were able to rapidly deploy ThingWorx because they had that connectivity through Kepware. And then it was very easy to learn and use how to do that. And it was actually codeless development enabled by the connectivity from Kepware into ThingWorx. So with all of that, I know I'm a couple minutes past my half-hour promised time here, but in terms of why Kepware, it really is the heart of the industrial control system. Being able to connect Kepware to pretty much all of the different devices on the shop floor enables you to then put those higher level applications in place in a much more rapid, much more effective manner, and utilize the information from all of those different devices on the shop floor. So with that, I want to thank you for your time this morning. If you have questions, please reach out to me at Tim at Visual Decisions. And you can also reach me at 630-957-8096. Again, a question of, can you send website link where the video will be uploaded? I will follow up with an email to everybody and when the video is available, and send that out to everyone in attendance. Any other questions? All right, thank you very much for your time today, and I will send out those follow-up emails within a couple of days. Thank you.